This video is going to be Chapter 3, Network Protocols and Communications for the Netacad CCNA Course 1. This is Chapter 3, Part 1 of 2. It will be broken down into 2 parts. My name is Jason Johnson, and thank you for watching this video. If you find it helpful and you want to be updated on future videos, just click the subscribe button down below on my channel, and you can also click like on the video if you found it helpful, or leave a comment down below if you have a question or just want to leave some information. Okay, well, let's take a look at this chapter. We're going to be looking at doing a quick introduction, rules of communication, network protocols and standards, and on the second part we're going to be talking about data transfer in the network. So Section 3.1, rules of communication. Why do we have rules of communication? Well, just like if I was going to talk with somebody and verbally, through audio, talk to somebody, and I was going to have a conversation. If I was speaking English and someone else only spoke German or French or Japanese, they would not be able to understand me if they did not speak English, or if I did not speak another language, German language or French language, and we'll just say French in this case. If I didn't speak French and they were speaking in French and I was speaking in English, our information, we could probably get along. We could probably use hand signs and we could probably hold things up, but we wouldn't be able to communicate effectively. In the same way, in the networking world, we need to have rules established so that we know how to communicate. So let's take a look at those rules. When we transmit information between two humans, we send information back and forth, and we have some rules set up that we say we need to speak the same language if we're going to understand each other. And one human says, I've got a message to send. I speak that message, or you write it down on a piece of paper and hand it to somebody, but at the same time it needs to be written in a language or written in a format that the other person would understand. We transmit that, we hand it off, or we speak verbally. The person receives it, and then they decode that information. So in the much same way with the networks, we have a node, or we want to send a message. It gets transmitted to the other side. We transmit it. It gets received and decoded. So we establish rules, and human communications between humans have established rules. We say if we're going to communicate with each other verbally, we need to speak the same language. If we're going to communicate through the written language, we need to make sure that we're communicating through a common language. And so we establish those rules to be able to translate and untranslate that. If I was going to handwrite a letter to you, I would write that down, and hopefully my handwriting is in good enough shape or well enough so that you would be able to read it on your end. And let's say that I wrote it in Egyptian hieroglyphics, and you understood Egyptian hieroglyphics, and when you open that up, you could look at those hieroglyphics and be able to understand that. Or if I wrote that information in French, you'd be able to understand that based upon those rules that we established. And so those rules allow us to say we have protocols in the networking world, and based on those protocols, we have message encoding. How is it encoded? How is it delivered? What's the timing of it? What's the size of those chunks of information? What's the size of those ones and zeros that go through the network? And then how do we format and encapsulate that information? So we encode that. We have our message. We encode that. We either write it down or we speak it based upon a common language. We transmit it, either writing it down or speaking it, and it gets sent through the airwaves. Received, decoded, and we can see. So if we're describing a sunset, and on the other end we get to, we have a sunset, the sun's going down, it's a bright burnt orange, on an ocean breeze, and then the other person has some commonality. They say, okay, I know what an ocean looks like. I know what the color orange looks like. I know what the sky looks like. So as you describe that the other person on the other end can understand it. So much the same way with the computer, we put information on there and it gets transmitted to the other end. We have a message, we encode it, we transmit it, we receive it, we decode it on the other end. And so we can also look at it in the way when we format and encapsulate, we can use the written word, or if we were going to use the U.S. postal system and we want to write a letter to someone, we write this letter, and John is writing a letter to Jane, and it just says they returned and here's the information, and they want to then fold that up or encapsulate that information and put that inside the envelope, and then it needs to be addressed. It needs to say who is it coming from, who is it going to, and how are we going to be able to transmit that. In this case, through the U.S. Postal Service, we put postage stamp on there. We pay for our tax on there, our postage stamp, and then we're able to send it on the other end, they open the letter up. They say, oh, this is for me. This was sent by the sender. So Jane says, oh, it's coming to me, Jane. It was sent by John. And yes, it got to me because it had the proper postage on there. They open the envelope up. They read the letter and they say, okay, here's the message. So they decapsulate it on the other end. And so that's an example of a personal letter where we have an identifier, a salute or greeting, the message content, the closing phrase, and then who is sending it. And much the same way we break down networking, we have a physical address hardware, we have our software address, we have a starting flag, we have a destination sender source, we encapsulate our data, we put our data in there with the contents of our message, and then we have an end frame to say goodbye. And we close the envelope up and send it. When we talk about message size, and when we communicate, you could probably have someone send you a message, but if we send too much at one time, we may not be able to understand that. So if the message is sent, you should see the sunset, it's beautiful, the colors are amazing. If the person doesn't understand on their end the colors and the information, or they send too much, or the message is too large, it might not be able to be received. So we have to make sure that our message size is set properly when we're sending that. So in a computer communication, the source host breaks long messages into small bite-sized chunks of information that gets sent across the network. And the main reason you do that is so that if one of the packets doesn't get through, then the next packets, they can replace it, and it makes communication a lot faster. So you have message timing. That's another concept that we need to understand in the networking world. And we say, what's our access method? What's our flow control? How many the timing of our messages, how they get sent out, and then our response timeout. If it takes too long for a message on the network, it collapses, or not collapses, but it's got a timeout, and it says, okay, it just ends. It says it does not transmit anymore. Or it doesn't get transmitted anymore. Routers don't send it forward. Networks don't send it forward. Now, one of the concepts that you need to get a good grasp and get a good understanding of is when we talk about unicast, multicast, and broadcast, and these are our delivery options. When you do a unicast, a source is broadcasting to one person. I shouldn't use the word broadcast. A source is sending to one node or one point, and that's a unicast. A multicast is where a source is sending to multiple, and then a broadcast means that it's sent out to everybody. And I just kind of think of a broadcast like a TV show, or where you just send it out to everybody. You send out a Wi-Fi signal and it just goes to everybody, and that's being broadcast, where a multicast or a unicast. And you need to understand these concepts because when you get into some of the networking and you say you've got a broadcast address, you need to have in your mind the concept of you know what a broadcast is. Or we say this is the unicast address. You need to know why it's saying unicast and what that applies to. And in the same way on a network, you have one source going to one node, and that's a unicast. A multicast going to multiple nodes, and then a broadcast going to all the nodes on the system. Okay, so let's look at network protocols and standards, and why do we set those? Why do we set protocols, and why do we set standards? And they are necessary in networking communication. We're going to look at why we have protocol suites. We're going to explain the role. We're going to take a look at the role of standards organizations, and then the TCP/IP and OSI model. Rules that govern communications. We have protocol suites to set and say why or how are we going to be able to communicate. So we have our content layer, we have our rules layer, and we have our physical layer. And you're going to see in a few minutes when we look at the OSI layer and the TCP/IP layer how these line up with that. So someone is sending a message, where's the cafe? So we say, what's the content? Where's the cafe? The conversation is we use a common language, we wait our turn to speak, and we signal when we finish. And that's the rules layer. And then we have the physical layer. That's actually being able to hear each other. So the content is our message. The rules layer is how are we going to transmit that message. And the physical layer is actually communicating. So, and let me go back to that. The roles of protocols, how the message is formatted. That's what a protocol sets up. It says what's the role of the protocol. It's how is the message formatted and structured. The process works by, or the process by which the networking devices share information, and how and when error messages are sent. So if you're getting errors, or if you're getting a lot of, if you're getting a lot of static, a lot of interference, And how is that information retransmitted? And then how do you set up and terminate data transfer sessions? How do you end communication? So the protocol interaction, we have what we call a protocol stack. And so our protocol stack in this case is HTTP, which would be a web page, or TCP, your internet protocol, and your Ethernet. And so you have different layers. So you have the application layer, the transport layer, the internet layer, and the network address. And an example of those would be over here, are your protocol stack: HTTP, TCP, IP, and your Ethernet. And we're going to get into those more. And as you take the Netacad course, you're going to get into more and understand those more. But for now, just understand it at a high level. So we have protocol suites, and there's industry standards that get set up. Some of the suites that we have, and you're probably familiar with the TCP/IP, you're probably familiar with the ISO, you're probably not familiar with AppleTalk and Novell NetWare. Those are still around. Years ago, back in the 90s, setting up Novell networks and working with that and working with those protocols. It's been a long time since I've worked with AppleTalk. However, I do remember seeing a question on the AppleTalk protocol suite on one of the certifications that I took. It was kind of one of those moments of, hey, how did that end up here? But it was a question based loosely around the AppleTalk protocol. And so we have these layer names, application, transport, internet, and network access. How do they connect? And they're broken down, and these are the protocols that we use. AppleTalk.afp. You're going to be most familiar with the TCP/IP in this course. HTTP, DNS. You're going to need to know ports on these. TCP, UDP. You're going to become very familiar with those. IP version 4, IP version 6, ICMP v4 and v6, and then Ethernet, frame relay, ATN. You're going to get very familiar with these terms. Although you're also going to see some from the ISO layer, but most of what you're going to learn in this course is in this area here. Just so you have a heads up on that. So the development of TCP/IP came about the first World IPv6 Day, June 11th, 2011. And yes, IPv6 has been around for a long time. It's just now beginning to become prevalent. And devices, because it takes a long time to get devices rewired and reprogrammed to the new layers. So there's 1,000 other companies for a worldwide trial. You can check that out on the internet and Google that. So when we talk about the TCP/IP protocol suite, some of the ones that you're going to need to be familiar with, DNS. You're going to need to be familiar with UDP and TCP. At the internet layer, you've got IP, NAT translation. OSPF, routing protocols that you're going to get into a little bit in the Netacad course 1, but you're going to see a lot more of that in course 2, 3, and 4, where you're setting routing protocols. And then your network access layer, your ARP tables, your Ethernet interface devices, those are at that level. Now, when we send a message, the protocol operates, or the protocol encapsulates that information. So we have our user data, we have our HTTP data, our TCP data, our IP packet, and then our Ethernet frame. And our Ethernet frame is saying how do we send that on the Ethernet, and that's the length of the frame or the size of the frame that we send. And that's all ones and zeros that gets sent, and it gets encapsulated into that information. So as you read that packet of information, you can decapsulate that and pull that information out, unless it's encrypted, and then it's a little bit harder to do that. But at the basic level, that's what we're talking about. And on the receiving side, it decapsulates that and unwraps it like an onion with layers. It unwraps it and receives that information. Okay, that was a high-level look at protocols and those. Let's take a look at standard organizations. There's open standards that we have, and you can go look these up, and I'll pause here for a second on the video, or you can pause those. You have IEEE, you have the TIA, you have the EIA standards, you have ICANN. You probably know ICANN from setting website names and organizing that. Same thing with Internet Assigned Numbers Authority, the IANA. So you can check those out, and I would recommend you do that. You may have an assignment in the course where you do that, but I would recommend you do that just to become a little more familiar with some of these organizations. Now, these organizations set standards, and they get together as a body of people, and they say, we're going to set standards for certain things. And so you have the structure or the hierarchy, and you may set a task force, you may have a group, and you may have working groups in, and they get together and they say, okay, how are we going to transmit Wi-Fi? How is Wi-Fi going to work? And we're going to upgrade the standard for Wi-Fi, and we're going to make it faster, and we're going to make it more broad range. And so they get together and they start working on it as a group of people, and then they come back together as the group, and then they roll it all up, and then they publish the information. And they say, okay, here's the new standard for, let's say, USB. Here's the new standard for USB and how USB is going to transmit for 3.0. Here's the speed. Here's the protocols. Here's if you're going to build a device that transmits on USB 3.0, here's how it's got to be built to be able to do that and transmit. And the IANA and ICANN, they set the TCP port numbers, domain names, and IP addresses. Now let's take a look at the IEEE here. They've got working groups. They've got, when you see the 802 group and you've been studying for networking, and you say, okay, 802.11 is a wireless group, and how did that, what is 802.11 and where did it come from? Well, there's a group of people, and they belong to the groups and study groups for the IEEE 802 working group, and that rolls up into the IEEE, and that gets published, and it says if you're going to have a wireless networking device, here's how it's got to be able to communicate with other wireless networking devices. Could you go out and create your own hardware to be able to, two pieces of hardware to be able to communicate with each other that's not on the 802.11 standard? Absolutely. You could go create your own devices, and they could communicate with each other. They just wouldn't communicate with other devices unless they were set to that standard. So for the same thing with when you're talking about cabling, you may not have thought about in the past when you grab a patch cable and you go to plug it into your computer or plug it into your server. You may not know that that's verified based upon certain standards of how that wiring is supposed to go. Why is the orange wire there? Why is the brown wire there? Why is the white blue wire where it is? Well, there's standards for that are set, and in the industry we try to follow those standards, or things don't work properly. Now, when we talk about reference models, we have referencing models for networking, and we have the two here that you're going to be most familiar with in this course, and you have the OSI model and the TCP/IP model. The TCP/IP model is in 4 layers. The OSI model is in 7 layers. I would recommend coming up with some kind of way of memorizing the layer, because you're going to be tested on the OSI layer in this course, and if you do anything in networking, you need to have a really good understanding of the OSI model. Whether you do, please do not throw sausage pizza away, I think is one. Some people go down. I remember it by going up. And so when I'm in when I'm somewhere and I say, okay, what's layer 3 of the OSI model? Please do not throw. Oh, throw is transport, and that's how I memorize it. And on the TCP/IP model, you can do NITA, NITA, or you can do ATIN. It's a little bit easier to memorize: application, transport, internet, network access. But you do need to memorize these. You need to memorize the OSI models, and you're going to need to memorize the protocol suites that come in each one of those. You don't need to memorize them all, but you need to know the common ones. So you need to know at the application layers, or that the application, presentation, and session layer, that that's where HTTP, DNS, FTP operates. When you get down here, that's where your network communicates, your physical and your data link layer. Or network access on the TCP/IP side, and that's your wiring, your wireless standards. That information is down here, but you do need to memorize this information. So when we're talking about the OSI model, you have 7 layers, and you have 4 layers for the TCP/IP model. I'm going to go back to the OSI, and you can look these up on the internet. There's plenty of models out on the internet. I would recommend memorizing these. Same thing for the TCP/IP, and have an understanding of what each layer does as well, and how they stack up against each other, how they flow into each other, or how they used against each other. Okay, so the first part of this presentation, or the first video in Chapter 3, we did an introduction of communications. We talked about the rules, and we talked about network protocols and standards. In Part 2, and I'll have a link at the bottom of this video, or I'll have a link here. You should see it either bottom corner, left upper corner somewhere. It'll be on here. And I think I will also put a link in the description for that. So if this video was helpful, click the like button for me, or not. I don't care. That's up to you. But if you have any questions, you can put those in the comments downstairs, and subscribe to my channel if you want to see updates coming out in the future, or if you want to leave feedback on what else you would like to see me do videos on. So I hope you have a great day, and thanks for watching.